Welcome to Civil Engineering Simplified Lectures. In the first episode, I have explained what are the various types of boundary conditions. Now in this episode, I am going to tell you about calculating the support reactions. So for this, let us first of all take a simple case of a simply supported beam which is subjected to a uniformly distributed load. For the purpose of understanding, let us take some values or assign some values for this. I will take about 4 kN per meter as a UDL, and let us consider this span as about 10 meters. I'll assign these supports as or indicate these supports as A and B. See, whenever there is an action on the beam, there should be equal and opposite reaction. So then only the equilibrium equation or equilibrium status will prevail. So now, while calculating the reactions at A and B, the first step would be, I will call the reaction at A as RA and the reaction at B as RB. Let me be more clear. So let us indicate this as RB. So first of all, as a first step for calculating the support reactions, we will assume this as the reference line, the reaction where RA is acting as the reference point, and take moments about point A. For this, as we know, RB is acting upwards and this UDL or the uniformly distributed load acting on the beam is acting downwards. So there must be equal and opposite reactions. So now when take moments about A. So while for taking the moments, we find that you all know that the definition of moment is force into perpendicular distance. So the reaction is RB, the distance is 10 meters. This must be equal to the downward acting force, which is acting at a distance of half the span length from point A. Let us see how we calculate this downward acting load. 4 kN per meter is the intensity. This is per meter, and the total load for 10 meters would be 10. We are taking the moment about point A. This is the total load intensity. This multiplied by the perpendicular distance. The reaction line of the UDL acts towards the center. Suppose if we call this as the reaction, the resultant, this passes through half the span of the beam, which is 5 meters in this case. So what I will do is half of 10. So this acts at a distance of 5 meters. So now the calculation is quite simple. 10 RB is equal to 4 into 10 is 40. Kilonewton per meter into meter will be kilonewton only into say 10 divided by 2. So this 10 and this 10 cancels out and RB works out to 20 kilonewton. So this is as far as the value of RB is concerned. Now how to find about RA? It is quite simple. From the principle of equilibrium, it says that the summation of all the vertical forces should be equal to 0. This is one of the requisites of the equilibrium equation. Hence, RA plus RB, these two are acting upwards. This summation of RA plus RB should be equal to the total downward acting load. In this case, the total UDL acting on the whole span is 4 kilonewton per meter and the span is 10 meters. As I said, 4 into 10 would be 40. This meter and meter get cancelled. Hence, RA plus RB is equal to 40 kilonewton. So in this case, RA only is the unknown and RB we already calculated, which is equal to 20 kilonewton. Hence, RA is equal to 40 minus RB, which is nothing but 40 minus 20 in this case. Both are in kilonewtons. Hence, RA finally would be equal to 20 kilonewton. I hope it is quite simple and you have understood how to calculate a simple reaction for a beam carrying UDL. Just to verify whatever we have calculated, these reactions are correct, we are going to apply this equation, that is summation of all the vertical forces to be equal to 0. We know that the total downward force that is acting which is equal to 40 kilonewton and this must be equal to RA plus RB. That means total downward force should be equal to summation of reactions which always acts upwards. Hence, in this case, we know that RA plus RB is 20 plus 20. So 20 plus 20 is nothing but 40 kilonewton. Hence, whatever we have calculated, the reaction for this simply supported beam is correct. So this is a cross check, simple cross check for calculating the support reactions for a beam subjected to UDL. Now, let us take another case. So this is case 1. See, always we are not having or encountering a case wherein we have UDL. Suppose in the second case, consider another type of loading which is a concentrated loading. So we assume that this concentrated load acts in the middle. For our simplicity or for understanding, I will call this as say 20 kilonewton. Let us take this span L as again 10 meters. It can be anything, L can be anything. So for in our case, we are assuming it to be 10 meters. And again, I am calling the two supports as A and B. And if we are representing the reactions, it can be RA and RB. RA at point A, RB at point B. So how to calculate? So we are proceeding again on the same principles as that of the last case. Now it is quite simple. In the first case we had a UDL. Now it is only a concentrated load. Hence our approach would be quite simple. I am proceeding on the same lines as we did in the first case. Take about A. When we take moments about A, force into perpendicular distance RB into 10 meters, which should be equal to 20. So this is, we have assumed it to be acting at L by 2, which is 5 meters. So the force into perpendicular distance for downward acting load is 20 kilonewton into 5. Always the moment has a dimension, or it is represented by kilonewton meter. Here you can see this is the force into perpendicular distance and the units will be kilonewton meter. Now it is quite simple. The next step would be calculating RB, which is 20 into 5 divided by 10, which is 20 kilonewton again. It is rather 10 kilonewton. So RB is 10 kilonewton. So the next step would be, if for calculating RA plus RB is equal to total downward acting load, which is 20 kN. Hence RA would be 20 minus RB. Hence RA also works out to be 10 kN. We can apply a simple check. As I told, the summation of all the vertical forces should be equal to 0. So here also we are cross checking our result, whatever we have calculated, whether it is correct or not. What I will do is, I will rewrite the equation sigma equals 0. Hence RA plus RB in this case will be equal to the total downward acting load, which is 20 kN. We know that calculated value of RA is 10 kN and calculated value of RB is also 10 kN, which is equal to 20 kN. So 20 kN upward force will be equal to 20 kN downward load of 20 kN, which satisfies the equation of equilibrium sigma equals 0. So this analogy can be applied to any type of loading and any type of or any span of the beam. In the next episode, I'll be telling you more about calculation of moments and shear forces for a simply supported beam. Hope you have understood better now to calculate the support reactions, and please keep interacting, and for any comments please write to the mailbox for your comments and reviews. Please do watch, subscribe, and happy watching and understanding. Thank you.